Now, why is factoring important? So let's start with factoring. First of all, what is a factor? What's a factor? If I say 2 multiplied by 3, what would that equal to?
A product.
Okay, so the 2 times 3 is what? What's the solution?
6.
6. Okay, so now 2 and 3 are the factors. 6 is actually the product. So factors are just 2 numbers you can multiply in order to get another number. Okay, for example, let me draw something. Let me draw a simple shape. And then if I say that this shape, this is 2 units and this is 3 units, if I say what is the area of this? Area of this yard. So what are we supposed to do?
L times W. Length
Exactly. Exactly. So we do the area, we write the formula area, which is length times width, and then we plug in the number, and then we have the result. You see, that's factors there. We just use factors in getting the area. Okay, so how about if I draw, the same yard, instead of using numbers, I will use expression. I can say this is x plus 2. Then I can say that this is x plus 3. And what is the area? Area is equal to what? Does it make sense now? So yeah, so we just have the same shape, which is a rectangle, and instead of having a direct number, they are putting some variables in our number. You see?
Excuse me?
Yes.
Do we have to write this down since
Yes.
this is a review?
Yes, it is. You have to, because you are going to submit it as part of your classwork today before the class ends.
Okay.
Yes. So now, are you getting the gist of what I'm about to trying to achieve? So we have another object, and the area formula is the same thing. True or false? This is multiplication, length times width. And so in this case, what is the length? What is the length?
X plus 3.
Exactly. So we have x plus 3. And what's the width?
X plus 2.
X plus 2. Okay. So if we want to get the area now, what mathematical technique do you think we need to use in order to multiply these two expressions?
Distributive property.
Thank you. So distributive property. So that's what we are going to apply now. You see, x plus 3 is a factor. X plus 2, I'm sorry, x plus 3 and x plus 2 are both factors, right? So now we are going to use distributive property. So we can just say equal to x times x is what?
2x.
X squared.
Oh.
Yeah, if it is x, sorry, it was my mistake. I said x plus x instead of x multiplied by x. It was my mistake. So x plus x is 2x, but x times x is x squared. All right, sorry about that. All right, you were right, I was wrong. So x times x is x squared. Then x times 2x, I'm sorry, x times 2 is what?
2x.
Yes, 2x. Then 3 times x is what?
3x.
3x plus 3 times 2 is what?
6.
6. And then we collect like terms. So what are the like terms?
2x plus 3x equals 5x.
5x plus 6 x
Then
squared,
plus 6.
and that gives us the area. That gives us the area. All right. Now here's the magic now. Here's the magic now. You see, we started, our topic was supposed to be factoring, right?
Mm-hmm.
So now somebody can actually give us this number and say factor this is the expression, factor the expression x squared plus 5x plus 6. You see?
Mm-hmm.
Have you seen this type of question before?
Yes.
All right. So that's the purpose why we are doing it. Factor the expression. So in that case, what are we supposed to do in order to factor it?
Find the factors, 2 factors of 6 that equal 5.
Okay, that's a good idea. But here's a better way to here's another way to put it. That's a very good idea. So find 2 numbers such that when you multiply it, it gives you 6. And when you add them, it gives you 5. So you can just say, besides, write product equal to 6 and sum equal to 5. So what are those 2 numbers?
3 and 2.
2 and 3.
Exactly. So now we are going to use that 2 and 3 to expand this 5x. So all we need to do is we say x squared plus 3, this is 3x plus 2x plus 6. You see? And then we now group them. After doing that, we will group it. We will group it. And look at this one. Look at x squared plus 3x. So what is the common factor in both of them?
3x and 2x.
No, I said x squared plus 3x. So what's the common factor there? This is x times x, and this is 3 times x. So the common factor should be x. So we have x bracket x plus 3. And then how about 2x and 6? What is the common factor there?
2.
2. Thank you. So we just write 2 bracket x plus 3. So you can see that we have a common factor, which is x plus 3 and x plus 3. So you just take one of them. You say x plus 3, and then you just combine this one. You combine this x and this 2 by just saying x plus 2. And this gives you the factors of the original expression. So that's how to do factoring. Meanwhile, also note that not all expressions are factorable. What did I say?
Not all expressions are factorable.
Exactly. So some expressions, if you want to factor it, no matter what you try, it's not going to work. So that's why you have other ways of solving expressions. Or sometimes when you factor it, you have a remainder. That's actually what happens when you're dealing with higher order polynomials. You try to factor it by long division, you end up having a remainder. You have certain factors and you have a remainder. Just like not all numbers, when you divide it, it will give you an even number. Some numbers, when you divide it, it will give you a whole number and a remainder. For example, 7 divided by 2 is 3 remainder 1, right?
Mm-hmm.
Okay, so now if it is for the type of expression, we had, which is this, is actually a quadratic equation. So since it is a quadratic equation, if we try and we were unable to factor it, we can actually use quadratic formula in order to solve it, and it will give us the same result.
Mm-hmm.
You see? So that's the purpose. So for clarity, let me just write the quadratic equation formula, which can be used in order to solve the same thing. Let's just write it for writing's sake, you know, so that you won't think that. So the quadratic equation formula is what? X equal to, it starts with minus b, take it from there.
I thought it was plus or minus b.
Starts with minus b, then plus or minus comes.
Oh.
Yeah, that's a good try. That's actually the kind of thing we want. You don't have to get anything right, but you need to make effort. So now, what should be inside the
I believe 4 AC plus.
Yes. Okay, 4 AC is somewhere here.
Oh, I'm tripping.
No, you're not. You're making effort. That's what we want. This is
Isn't it b squared minus
Yeah,
4ac?
Yes.
Yeah.
Yes. Over 2a. All right. So if, for example, this quadratic equation is not factorable, the next thing we are going to do would be to use this formula. And here's another good news. If you use this formula, at some point, it will give you a number that you cannot really evaluate inside the square root sign. And in that case, it gives you what is called complex number. So that's